Alright guys, today we're going to be looking at slope using what we call similar triangles. So we've already been using slope where we plot 2 points and we look at the constant rate of change or the change in y over the change of x. And we were only looking at one triangle at a time, but now we're going to look at more than one and see what happens with our graphs. So when we look at this, it says plot the points, draw the line that runs through the points extending to the end of the graph. Then we're going to draw 2 different right triangles that could be used to calculate the slope of the line and label them triangle A and triangle B. Then we're going to show how to use those triangles to calculate the slope. So what we're going to look at is here to help us out just a little bit. So let's go ahead and get ready for that. So you're going to need a ruler if you have one. I would use a couple of pens with different colors or markers if you have them, since we're going to be looking at more than one triangle. Okay, so we'll go ahead and get those supplies ready and go ahead and get started on that. All right, so let's go ahead and look and see what we're going to do today. Just got to move my materials around too, okay? So the first thing I'm going to do is I'm going to plot my points. So we are going to plot when x is -3, and we'll zoom in on the graph on this, and then we'll zoom back out to see the other part. So when x is -3, y is 0. Start at the origin, x is -3, y is 0. Then start back at the origin when x is 5, y is 8. Then my last ordered pair when x is 2, y is 5. When x is 2, y is 5. So those are my 3 ordered pairs. So I'm going to connect the dots. Make this a line, connecting them all the way on that graph. And so this line is going to go on and on and on forever. Okay? So now what we need to do, it says draw 2 different right triangles that can be used to calculate the slope of the line. Label them triangle A and triangle B. So basically, we just need 2 triangles. So let's see, I'm going to use different color for triangle A. So I'm going to connect this first dot to the second one. And again, it doesn't matter if you draw above or below the line, but I like to do above on this situation since I have a positive slope because it's the vertical change compared to the horizontal change. Remember the change in y over the change in x. That's that constant rate of change, which is actually slope. So I'm going to call this triangle A. So let's see how many I go up. 1, 2, 3, 4, 5. So I went up 5 and over 1, 2, 3, 4, 5. And I like to draw those arrows because it helps me out to say if I go up vertically, that's a positive 5. And if I go to the right horizontally, that's a positive 5. And 5 divided by 5 is 1. So my slope is actually 1 because every time I added 5 y's, I added 5 x's, and so those reduced down to 1. 5 divided by 5. Look at that as a fraction. Okay, so now what I'm going to do is I'm going to draw another triangle. So I'm going to draw this triangle. Let's use a different color. So I'm going to connect this dot to this second dot. So this triangle looks a lot smaller. But let's see, vertical change compared to the horizontal change. So from this ordered pair, when x was 2, y was 5, and I'm going to, when x is 5, y is 8. 1, 2, 3, so I go up 3, 1, 2, 3 to the right. So even though I went 5 up and then 5 over to the right, and 3 up and then 3 right to the over, this is a positive 3 divided by a positive 3, and we get 1. So did we get the same answer for each triangle? Yes, we did. At first, you might think that 5 to 5 and 3 to 3 are different, but remember, we're looking at these kind of like fractions, and we're going to reduce them. Okay, so why or why not? We're going to say, I got the same answer because the rates are equivalent, and similar triangles are actually proportional. So if something is similar, they're a proportional relationship, and we're going to talk about that as well. So we're going to say, why or why not? Because the slope, the constant rate of change, reduced to the same number. And in this situation, they reduce to 1. So I'm just going to put 1 in parentheses. Okay? What this really means is that every time you have a change in y, 1 is the same thing as 1 over 1. So in order to make every ordered pair on this graph, you're going to go up 1 and 1 to the right. So if I went up 1, 1 to the right, 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 and so on, I would get every single ordered pair on this graph. So these similar triangles are proportional, and that means that they're reducing down to the same thing. So 5 to 5 and 3 to 3 reduce down to the same thing. Okay, let's try a couple more, because I know after one example you can't just get it magically. So now we've got a new set of ordered pairs. Okay, so we're going to draw 2 different right triangles again and calculate the slope, and we're going to draw these with our ordered pairs first. So first we've got to connect the dots with the ordered pairs, and then we can draw our triangles. Okay, so on this one we're going to do -4, 7. So when x is -4, y is +7. It's right there. Then when x is -2, y is 3. And when x is 1, y is -3. So again, it's really important that you remember if x is ordered pair first, left to right, and then y, we're going to go up and down. Always start at the origin. If you graph your ordered pairs wrong, it's going to throw everything off. So we really need you to be careful. And again, that's why we've been practicing graphing since elementary school. So we're going to connect the dots. So we can see that this is a negative slope already. So when we have our similar triangles, we should have a negative slope. So let's do our triangle A, the change in y over the change in x. Now I'm going to change this one up a little bit. It doesn't have to be between the first and second, the second and third point. So I'm actually going to go from the first ordered pair to the third ordered pair. Now the reason I did this triangle below the graph is just to see that I'm going vertically and then this way horizontally. If I did it above, I didn't want to say accidentally use the wrong number in the wrong spot. But if you did do it a different way, you might get the same answer. So let's see. The change in y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I go down 10, and I'm going to go over 1, 2, 3, 4, 5. We're not stopping at the y-axis, we're stopping at that ordered pair. So that's really important for us to know. So if I go down 10, anytime you're moving down, you're going toward the negative, so you say -10. And anytime we're moving right, it doesn't even matter if I'm still over here and I'm moving to the right, I'm going to toward the positive. So anytime you're going down vertically, we're gonna note that with a negative. If we were going up, it would have been a positive. Okay, so that's just something we need you to be mindful of. So -10 divided by 5 reduces to -2. Or you can even say -2 over 1. That's the same thing as -2. Because if you divide both of these by +5, that would be your fraction, and anything over 1 is itself. Okay, so we got the slope for that one. So this is my triangle A. So now I'm going to do triangle B. I'm going to do this one above just to kind of change it up. So if I went from this second one to here, well, we have to kind of think about it. We need our vertical change first, which is not left to right. So vertically, I'm going up from this dot to this one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this is where it looks a little different. Change in y over change in x. I went up 6 and then over 1, 2, 3. 3 to the left. So up 6 is +6. 3 to the left is -3. But both of these, well, 6 divided by -3 is -2. So even though they start off looking differently, forgot to label this triangle B, you can see that they reduce down to the same thing. So, do you get the same answer? Yes. we got the slope as -2. So we're going to say yes. We can even say when it was reduced. So the explanation for why or why not is similar triangles are proportional. So when we have similar figures, and in this case we have similar triangles, that's like saying, if you think about a regular fraction like 2/4, it reduces to 1/2. Those are proportional because they reduce down to the same thing. All right, let's look at another one. We've got a couple more examples, and then you're going to have some independent practice. So it says, plot the points -7, 0. So when x is -7, y is 0, so I stay on the x-axis. When x is -3, y is 1. And when x is 9, y is 4. Oh, you know what? I did this one wrong. It says -3, +1. That changes it up. That's right here. So I'm just going to put a little x through that one because we're not using that one. -7, 0, just double checking, -3, 1, and then 9 and 4. Okay. That's why we double check our answers. Make sure we plot them right. So here's my line. And sure enough, over here, we predicted this was a negative slope, and sure enough, it was. So this one should have a positive slope because it's increasing. So again, that's something that you want to think about before you circle if it's positive or negative. Okay? So let's look. We want to make two triangles again. So I'm going to use my triangle A, and I'm going to connect this left dot to this first one. And that's going to be my triangle A. It's kind of a small triangle, but here again, it's a right triangle. Change in Y to change in X. So I did this again above because I see the vertical change here. I went up 1, and then I go 1, 2, 3, 4 to the right. So you have to count exactly until you land at that dot. You're not going to stop right here because that's not where that ordered pair is. Ordered pair is, it's right there. So if I go up 1, that's a positive 1. 4 to the right, that's a positive 4. So there's my slope for this one. So triangle B, well, I'm going to change it up and I'm going to do this one below, just so you can see it more than one way. This is triangle B. Okay, so the change in Y, which is my vertical change, to the change in X. So I'm not going to move left to right first because that's my change in X. So I need to see the vertical up and down. So if I go from here, 1, 2, 3, I go down 3. If I moved 3 down, now I'm going to move over to land at this one. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went 12 units to the left. It's a weird arrow. There we go. Make it a little better. So if I go down 3, that's a -3. If I move to the left, that's a -12. So those look a little different, but if you stop and think about it, -3 divided by -3 is 1, and -12 divided by -3 is 4. So here again, once you reduce them, you can see that we have that positive slope of 1 to 4. So every time I'm going up 1 in the graph, I'm going to go 4 to the right, and that's going to be every single way I can get an ordered pair on this graph. And I'll prove it to you. If you look right here, let me see. If you go up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4, you can see that that's how you can create these ordered pairs. So the whole point of finding this constant rate of change, this slope, is that you can use the slope to create every single ordered pair continuing on this graph. Okay? All right, let's do 2 more examples together, and then we'll get you some practice problems as well. All right, so this one says, compare the slope of the line using similar triangles. So we're going to make a large triangle and a small triangle, which is already actually there, but it's a little hard to see on their paper, so let me show you. They have this large triangle right here, this right triangle, and then they have the smaller one right here. So I'm going to put an L right here and an S right here. So it's a little bit easier for you to see on your paper. So we want the change in Y over the change in X. So my vertical change from this ordered pair, I'm going 1, 2, 3, 4, up 4, and 1, 2, 3, 4, 5, 6, 6 to the right. So if I go up 4, that's a positive 4. 6 to the right is a positive 6. Okay, let's look at the smaller triangle. Change in y over the change in x. So this one I'm going vertically up 2 and horizontally 1, 2, 3 to the right. So up 2 is a positive 2, 3 to the right is a positive 3. Those don't look alike, but remember that you need to reduce. Once we are reducing, we are showing that our constant vertical change is over our constant horizontal change. So we can reduce this by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So 4 to 6 and 2 to 3 do not look the same, but if they reduce to the same number, then that means that they have the same slope and they are proportional. These triangles are proportional. And look, if I go up 2, 1, 2, 3 to the right, 1, 2, 3. There's an ordered pair. Up 2, 1, 2, over 3, 1, 2, 3. There's your next ordered pair. So that's what we are looking at. So always want to reduce your slope so that you can see that that's your true slope and that constant rate of change in this situation. All right, so my larger triangle right here, they did above my line, and the smaller triangle, they also did above the line. Again, it doesn't matter which way you do your triangle, either above the line or below the line. These were both above or below the line. You just have to be careful with your numbers, okay? So this one, before I do any math, I see that I have a negative slope. So that's something that I want to make a prediction on. Change in y over change in x. That helps me make a prediction on the type of slope being negative slope, so when I find the actual number of the slope itself, I know that I should be looking for a negative answer choice. All right, so this large triangle. So my vertical change is up and down. So I can say 1, 2, 3, 4, 5, 6. So from this point, I'm going up 6. And then 1, 2, 3, 4 to the right. So up 6 is positive 6. I'm sorry, I said 4 to the right. I meant to say 4 to the left. I drew my arrow right. I just realized I said that wrong. When I go to the left, that's a negative 4. But we can reduce these numbers by 2. 6 divided by 2 is 3. Negative 4 divided by 2 is negative 2. So that's what we're looking for. All right, so now let's look at my smaller triangle. Vertical, change in my vertical compared to my change in my horizontal. So let's see what we've got. So from here, I go 1, 2, 3, up. That's how I'm vertically changing, as I'm going up 3. 1, 2 to the left. So going up is a positive 3. Going to the left horizontally is a negative 2. And sure enough, we have the same slope. So I can go 3 up and 2 to the left every single time. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I get every ordered pair that's going to be on this graph. Okay, so this is how we can make more than one right triangle, and these are called our similar triangles, to see that they are proportional because they reduce down to the same thing, and that means that when they reduce down to the same thing, they're going to have that slope be the same.